Welcome back. Still on mean deviation, but this time around, how to find the mean deviation of an ungrouped frequency distribution. The formula is still almost the same, except for the fact that we have the introduction of f, and f here mean frequency, of course, because this is a frequency distribution, unlike the previous video when we had a simple series or a set of values that we didn't need to include the corresponding frequency of each x values. But this time around, since we have a frequency distribution, we have to include the f values or the frequency of the x values. So the formula is still the same. Here we have the absolute deviation, the two straight bars. The two straight bar means absolute value. Absolute value of what? Absolute value of x minus x bar. X minus x bar simply means the deviation of the x values from the mean. The deviation of the x values from the mean. X bar means mean. X are the x values. So the deviation of the x values from the mean, that's what x minus x bar means. So whenever I say the deviation from the mean, I'm referring to x minus x bar. And this time around, we're not just considering the deviation from the mean, we are considering the absolute deviation from the mean. So it means that when you take a subtraction, respective of whatever its sign is, whether it's negative or positive, it doesn't matter. We just want the value. So that's what we mean by absolute value. Then you multiply by the f value, you multiply by the f values, then you sum them up. So I'm supposed to include the summation symbol here. You sum them up and then you divide by n. And do not forget that when we are dealing with frequency distribution, n is the same as the summation of your frequency. So n is summation f. So quickly, I need to correct this formula. So this is the summation of f times the absolute values or the absolute deviations, all divided by n, where n is your total frequency. So let's work an example quickly. We have this ungrouped frequency here with the mean deviation formula right here. So we have our x values and their corresponding frequencies. So we can start calculating. To start calculating, look at the formula. The formula says the summation of f times the absolute deviations. To get your absolute deviation, we need x minus x bar, which means that before we can start any calculation, we need our x bar first. We need the x bar first. So we need to find our x bar, and x bar is the same as your mean. X bar means mean, and mind you, this is an ungrouped frequency distribution. And if I'm to remind you of the formula for the mean for an ungrouped frequency distribution, it will be summation f times x over n. Summation f times x over n. So let me put that down in blue. In blue. So we have summation f times x over n. So we have our x, we have our f, then we can get our f times x colon and fill it up. So this means f times x. These are your x values, these are your f values. So for the first one, we're going to have, for f times x would be 3 times 0, which is 0. 1 times 5 or 5 times 1 is the same thing. 5 times 1, 5. 4 times 2, 8. 3 times 7, 21. 4 times 8, 32, and then finally 3 times 5, 15. Then you get, after getting your f times x, then you sum them up. Summing them up, you can always get your calculator to get your 0 plus 5 plus 8 plus 21 plus 32 plus 15. That would give you 81. The next thing, to find your x bar, so we found summation f times x, which is 81, divide by n, and do not forget that n means the total frequency. Total frequency, which means you are going to sum up all your frequencies: 3 plus 5 plus 4 plus 7 plus 8 plus 3, and that should give you 30. So to get your mean, that will be 81 divided by 30. 81 divided by 30. We can bring back our calculator. 81 divided by 30. Our mean is 2.7. So you can have a colon for your mean. Doesn't matter. So let's call that the x bar colon. Remember, your mean is constant. It remains the same throughout. So we can just write out 2.7, 2.7, 2.7, 2.7, 2.7. The mean remains the same, 2.7. Up next is to go back to our mean deviation formula. We found our x bar. The next thing is to find the deviation from the mean, which is absolute value, the absolute values of all the x minus x bars. So right here we can find x minus x bar. Do not forget, these are the x and these are the x bar. So those are the two columns that you are trying to subtract from each other. Alright, so we have 0, which is the x, minus 2.7. 0 minus 2.7 is minus 2.7. Okay, let me just bring out the calculator. It's just help out. Okay, says I'm going to be blocking the screen. 0, 1, 2, 3, 4, 5. So I'll just write the x values here. For the x values, we have 0, 1, 2, 3, 4, 5, because the calculator is going to block the view. Okay, so we can start with the first x value. We have 0 minus 2.7. You can see we have negative 2.7. So because we are to find the absolute value, we just write 2.7. The next value, the next x value is 1. So right here we have 1 minus 2.7. That's 1.7, taking the absolute value. The next is 2. We have 2 minus 2.7, 0.7. The next is 3. That's 0.3. Next is 4, 1.3. Then followed by 5, we have 2.3. So you can rub this off. 2.3. Back to the formula. Having done that, what does the formula say? The formula says that now that we've found x minus the absolute value of x minus x bar, then we multiply it by f. Multiply it by f right here. So we just create a new colon for f x minus x bar. So that means that you'll be multiplying this, all the values of the f column by all the values of your absolute deviations. So let's do that again quickly. I think I'll just write out again the f values. So the first f value is 3, then I have 5, 4, 7, 8, and 3. Those are the f values. Then I can bring up my calculator now. Okay, so let's pick the first one. We have 3 times 2.7. So we have 3 times 2.7. This is 8.1. The next f value is 5, and its corresponding value is this. So we have 5 times 1.7. Let me see if I can center this. Oh, great. So I just center it so we can see them. 8.5. The next is 4 times 0.7. So that's 4 times 0.7. We have 2.8. The next is 7 times 0.3. So we have 7 times 0.3, 2.1, followed by 8 times 1.3. 8 times 1.3, we have 10.4. And finally, we have 3 times 2.3. 3 times 2.3. Here we have 6.9. 6.9. So back to the formula. Back to the formula. The formula says, after you found your f multiplied by the absolute mean deviations, the absolute deviations, then you can sum them up. You sum them up. That's what the formula says. So let's do as the formula dictates. So let's sum up. This is the f times the absolute deviations. Then we can just sum them up by saying all of this plus all of this. Then we get the value here. So let's move on. So I just draw a bar here to signify or denote that I'm summing up. Then we can sum up 8.1 plus 8.5 plus 2.8 plus 2.1 plus 10.4 plus 6.9 plus 6.9. So altogether we have 38.8. The next is to find, according to the formula, the next is to find n, and n means your total frequency summation f, and this is your total frequency 30 right here. So we just employ the formula. That means that the mean deviation equal to 38.8 all over n, which is 30. Then we'll summon a calculator again. See right here we have 38.8 divided by 30. We have 1.29333. Like I would always say, approximate to, you're free to approximate to 3 decimal places, 2.93. So that's just as simple as that. If you have any issue, you can always watch the video again. and practice along with me. All right, I'll see you in the next video.